we want to really push for going further away from Earth. I think we want to be careful not to be called like a space weather analysis tool.
Right. Yes.
Because, I think there's a really fine margin between the purpose of what we're trying to achieve with ours. We've recently started to call it, we want it to be the Google of space engineering.
Hello everyone, and welcome to Advanced Engineering Talks, a podcast created by the Advanced Engineering team. AETalks brings together some of the newest and most innovative minds in engineering and manufacturing to help better the future for our industry. We hope you enjoy the series.
Okay, hello and welcome everybody to Advanced Engineering Talks, another edition where innovation never sleeps. I'm delighted to be joined today by Sophia Ahmed-Ashford, who is lead electronics engineer at startup company Space DOTS, which we're going to have a bit of a chat about in a moment. And also she's a former Mercedes F1 engineer, which is quite interesting. Sophia, welcome. It's lovely to see you. Thanks for joining us.
Yeah, hi, happy to be here. It's nice to see you again.
Yes, you too. I thought, one of the reasons I sort of wanted to chat to you was recently you've had some really interesting recent news lately about Space DOTS and a milestone in terms of your data dot payload that's recently been successfully launched with SpaceX, and I think as we speak is now orbiting Earth.
It is very exciting.
Exciting indeed, because tell us a bit about that and what it's all about and what the aims are and how it's all come about.
Sure. Maybe I should start with a small background on Space DOTS itself.
Absolutely, yes, you should. Yes, good point. And you're quite a new startup, or the last few years, yes. Is that correct?
Exactly. Yeah.
Yeah. Go ahead. Yeah.
3 or 4 years old.
Okay.
So definitely on the early stage side.
Right.
But yeah, Space DOTS is a startup at the moment that we actually started as I want to say like a materials. But the intention was to test materials in space,
right,
to be able to introduce new materials into the space industry and reduce the error of using those new materials in space and reduce the cost and time to validate those materials in space.
Right.
Essentially because, so much of materials testing for space components is done on Earth, and there's this cumulative error effect of not being able to have all of the space conditions in one place at one time. Right. So the idea was born out of, well, why don't we just take these materials straight to space, test them there, and that would start to kind of give more confidence in the qualification of them. However, from that, we've actually realized there's a much bigger need in the space industry and a bigger vision, that space environmental data itself is not mapped well enough, or at least it's very fragmented or it's outdated. And we were going to be collecting this data regardless for the purpose of testing these materials. And so that was what this first data dot that's now launched was a prototype of. It's got a bunch of sensors on it to pick up information about the actual space environment itself. So that's, including radiation, magnetism, gravity levels, all sorts like that. And we've realized there's actually a much bigger market to try and share that data with other spacecraft companies, satellite companies, and we've slightly pivoted now to becoming a bit more of a SaaS platform, where people can access this data. And the intention of that is still to reduce over-design, reduce cost, reduce time to launch, but in a slightly different way to before. The materials, of course, are still important, and that's still kind of at the back burner, but we now want to focus really on that space environmental data.
That's interesting. So it's almost that sort of as a byproduct of your original kind of main aims, you're finding a sort of perhaps an even better potential market stroke revenue stream going forward. It's often how these things happen, isn't it? I suppose sometimes serendipitously, as it were. And so some of that information, that what sort of people might use that, and for what purposes? Would that be other people who want to put things into space, I suppose, satellites and so on,
Yeah,
in
exactly.
general?
Yeah. So
Mm.
obviously, when you're designing satellites, spacecraft, whatever it might be, you're trying to understand the environment that you're going to be operating in. And at the moment in time, there are data sources, 100%, but they're all in different places. They're not combined into one. The data might be from 10 to 20 years ago.
Right.
Not all of it is open source. A lot of it is behind closed doors of obviously all the big primes. And what we want to do is with our data dots is collect proprietary data that
Right.
we want to be like the most accurate, the most up to date as possible, as well as still aggregating historical data and to
Yeah.
bring that all into one platform. And so that people are well informed about how to design best for the orbit that they might be operating in.
Right.
And especially now as we're going further away from the Earth towards more, obviously Leo is actually quite crowded, I would say. But as we're
Right.
going to other orbits further away from Earth, especially towards
Right.
the moon,
Yes.
it's really unmapped. There's not a lot of data about what's going on over there. And as we're racing back towards the moon, it would be extremely helpful for the industry to have that data to really design the best possible performance of their spacecraft and the least risk and like failure.
Yeah, of course, especially when they've put a lot of money and effort into
Exactly. Yeah.
into getting it up there, and also there's a lot of stuff out there, isn't there? I guess
Yeah.
space junk and debris and things
Yes.
like that. Does that come into it quite a bit then, I'm guessing, in terms of mapping that out, and how I can imagine that's a real concern for people for who are trying to get out there.
Yeah. Space debris at the moment is a huge topic. And it's funny enough one that came up a lot at Ignite Space, the conference I was at over the last 2 days.
Oh, right. Yeah.
We are not at the moment in Space DOTS looking at space debris that much.
Okay.
The reason for that, it's already a very concentrated market. There are a lot of companies focusing on that.
Right.
It could be that there's the potential that we partner with someone, that we bring that data in to still bring it into the platform, but we don't want our focus to be on space debris just because there's a lot of great companies doing that already.
Fair enough. Yeah.
And they're
Yeah.
doing a great job of it. So we don't want to reinvent that wheel.
Yeah. Yeah. That's interesting.
But you're
Yeah.
completely right. It's a real concern for the space industry at the moment in both how to operate your satellite and how to mitigate the risk of collisions, and how do we actually remove a lot of this debris now, because it is becoming space junk.
Some of which I believe is quite potentially recyclable and very useful. Is that correct? And I think some of the companies you might have been referring to there are sort of looking at that idea, aren't they? Are sort of
exactly, yeah,
collecting it and
which is super interesting. Actually, it's a great concept. It's just kind of bringing that to reality and the logistics of doing so. But it makes complete sense. I think there's a real concern as well with like micro debris at the moment, which is potentially more of a risk because it's really hard to detect. So there's a lot of companies who are trying to focus on micro debris detection now.
Interesting. Yeah.
I think it's something like we can only detect, I don't know, above a centimeter or 5 centimeters. I can't remember exactly what the threshold is.
Really? And it doesn't need to be big to do a lot of damage at those
not
speeds.
At all.
In that
Exactly,
environment, like a fleck of paint or something.
Exactly, yeah.
I can't imagine how difficult that must be. It must be like looking for needles in haystacks or something. I don't know, but
exactly.
Very,
But there's some very cool technologies coming out to detect that.
So, I mean, how do you know, for instance, just, talking about the debris thing quickly still, that you are going to, or how does anybody who's putting anything around at the moment know that the satellite is healthy and safe and in orbit? Because I was looking on your announcement, and it's saying telemetry data. I'm guessing you're getting real-time telemetry data, and it sounds great. So, are you Are you confident that that particular orbit is just not, not getting in the way of the debris?
Sure, yeah. So we're currently a hosted payload. So we sit on top of another satellite. So D-Orbit are our provider of the satellite.
I see. Right.
So they're very much more in charge of ensuring the safety of the payloads, to ensure that they're operating within the right orbits, mitigating any collisions, etc. So yeah, that's a bit more on them to make sure that all their customers, for example, will be safe. And I suppose the most we can see from our side of the data is that our data is healthy. It's looking as it should do, and I honestly think they've got quite a lot of experience at D-Orbit now with how to operate satellites, and it's very much on the operational front rather than the design front of the payload.
Right. And so I guess my question, natural question next is, you are a startup. You probably, I know you've been getting some great funding, and you've raised a lot of funding and investment, which is great. I guess the next step to sort of become commercially viable yourselves, or is that on the horizon, or is that started yet, or how do you think that will work, and over what sort of stage? It sounds like what you're doing with the creation at the moment is getting almost like a comprehensive database, and updated, that you'll probably update of what's out there in terms of the environment, and then you'll perhaps want to sell that on for some sort of access. Is that the idea?
Yeah, exactly. So yeah, there's a couple of things to pick up there. You're right, we've had a pre-seed round before. We're currently going through our seed round. So we are still looking for investment. And I think as many startups, especially in the space sector at the moment, will tell you, it's been a very difficult season to raise in. So Bianca, our CEO, is out there knocking on all the doors for sure, and fingers crossed. There's definitely some positive movement, so that will all be good. But you're completely right, we are trying to create that customer base now. Now that we've launched our first hardware into space, we've proven that we can do that. We've got data back that looks healthy and useful, and obviously that's super exciting. And now it's the next steps are to create this demo of this SaaS platform, and to kind of show other players in the industry how they could interact with this platform, how it could bring use to them. And you're absolutely right, access to that. Initially, we want to have kind of like a beta freemium service, but eventually that will be subscription based, and it's something we're talking about at the moment. What's the most useful way for raw data is raw data, but the value comes from adding insight to that data.
Yes, of course. Yes.
And so that's what we really want to focus on, is not necessarily selling raw data, but actually to sell models of data, insights, predictive analysis.
Yes.
And that potentially is more useful to other companies, as the data has already been processed, filtered, and adds a lot more value. So that is the general idea behind it. And that's exactly kind of the stream we're in now, is to develop that software platform while still iterating our hardware. So there's a lot going on at the moment.
Oh gosh, I bet there is. Yeah. No, it sounds a great way forward though, and it's got to be absolutely vital as a information service. I mean, are you at Space DOTS pretty much the only player sort of doing this, or is it difficult to say? I don't know, because it's going to be proprietary data that you have as well, isn't it? So
yeah, exactly. So there is definitely some competition in what we're doing, which is never a bad thing. I think we will be unique in the sense of, like you say, we're going to have our own proprietary data. We want to really bring in new and old sources of data. And the really big one is that we want to really push for going further away from Earth. I think
Yes.
we want to be careful not to be called like a space weather analysis tool.
Right. Yes.
Because, I think there's a really fine margin between the purpose of what we're trying to achieve with ours. We've recently started to call it, we want it to be the Google of space engineering, so that this is your go-to platform to understand everything you need to understand about the environment you're acting in, what requirements you need, what standards you need to abide to. So it could really develop into something quite big. And anyone else that we've seen doing something similar, there's a couple of like private companies, but they're very much sticking to LEO, very radiation focused, and not a holistic suite of all the data.
Right.
The flip side of it is government agencies do have open source data. So NASA and ESA is quite hard to get access to. You have to go through a lot of forms and loopholes. And with that data, it tends to be from 10 to 20 years ago, the ones that are actually open source. And so that's where we're trying to find our niche of the value in what we're doing.
Right. Yeah. Yeah. And so you're going further out, hopefully, is
Mm-hmm.
The mid to longer term, I don't know, plan. But so how are you going to start getting that further out? Will there be people again that you can work with who are planning to go further out
Mm-hmm.
in the orbits anyway, as it were?
Yeah, so our plan actually is to create our own platform. So if we were going towards away from the LEO towards Lunar, we do want to become our own platform, and not be reliant on someone else. So that's an extremely exciting upcoming project. We want to start looking at that within the next year or so. So for me as an electronics engineer, that's going to be a lot of fun. But we want to start first with demonstrating kind of constellations in LEO. So it's kind of like a staged process. Because at the moment we've just got our one data dot. That was a very like proof of concept. We want to move to a constellation, and then after that we want to be operating our own platform, so that especially towards Lunar, there's not many people who are doing ride shares or the equivalent. And so we want to be independent in that sense.
Right. Interesting. Yes. Yeah. I guess that gives you much more control as well, doesn't it? And
exactly.
I mean, would you look at that sort of being launched from a sort of UK type base, or do you not see that as realistic? Because I'm guessing this launch was from the US, was it? If it was
from Vandenberg. So it was on a Transporter 12, the SpaceX rideshare platform. And so obviously SpaceX have an incredible hold on the launch market for sure. It would be lovely if it could be UK based. However, I think potentially not realistic for a couple of reasons. One is, and this I'm just saying, I'm not the best at space operations, but I'm not sure the UK is the best place to launch from necessarily to get into a lunar orbit. It might not be the most efficient place to launch from.
Fair enough.
And also, I think it's nice to see the UK launch market building at the moment. I think there's been a huge investment from the government into Orbex recently as well, and so that tide is turning a little bit, but I think it's still going to take a fair bit of time before the UK is a real player in the launch market. But I do hope to see that happen for sure.
Yeah, that would be great. Okay, that's really interesting. And so it sounds like, I mean, how many people have you got working there at Space DOTS? Is it sort of, obviously it's pretty small, but are you based in different parts of the world as well? Like, or are you mainly based here in the UK?
Yeah, so we're mainly based here in the UK. We're a London-based office, and we are a very small team. There's only 9 of us. And we are trying to achieve everything on this big vision with the 9 of us, which is always a lot of fun. But I think obviously as we go through our seed round and get that funding, then we will be looking to hire more into certain areas that we need to push for. But at the moment, everything we've achieved so far has been with a very a small team, but a productive team for sure.
Yeah, yeah. And having met Bianca, of course, and she has
Yeah.
spoken at the Advanced Engineering Show, I think a couple of years ago, and it was great to have her on board. She's such a great kind of ambassador, isn't she? You know, for
Absolutely, yeah.
what she's doing. So I can certainly see why she's you know, there fronting it all up in terms of potential in getting investment in and so on, and the passion that she's got
Absolutely.
in that regard. But which I'm sure you all have, by the way. But especially if
Yeah.
it's a nice, quite a close-knit team. But
Mhm. No, I think even from my side, to have joined Bianca's company, especially as a young woman, it's really exciting to see someone like Bianca really pushing
yeah,
forward in the industry, in an industry that's largely male dominated.
absolutely.
So I think for a lot of younger women in the industry, seeing
Yeah,
her and being like quite a strong voice
yeah,
is really quite inspiring and
it,
exciting to see, because it is changing. And you can
yeah,
kind of see that by the people she surrounds herself with, and
yeah,
the people who
yeah.
come up to her.
Right.
So yeah, it's
Yeah.
really cool.
Probably, you know, younger and more diverse and so on.
Exactly.
And I did notice, I'm glad you brought that up about the whole, you know, women in manufacturing and engineering in general thing, because it is something that, you know, we hear, excuse me, we hear a lot about it across all sorts of sectors related to engineering and manufacturing, with regard to the show as well. And you know, we do try and you know, find ways of facilitating what is really simply an underused huge pool of great talent,
Yeah.
potential talent that we need, that needs to come through, you know. And we've talked a lot about STEM and, you know, how people pick it up or not, as they may do in earlier years. And
Mm.
I guess perhaps leads on to my next question about yourself, really, as a woman in this company, but also in the industry in general.
Mhm.
What sort of I don't know, what inspired you originally to get into it all?
Yeah.
Would you say? Mm.
Yeah, I guess it's been quite a journey, really. So when I
Mm.
was growing up, I always just had an interest in technology and how things worked. Um, Loved taking stuff apart and looking at
Right.
circuit boards inside, and
Yeah.
just, you know, at a really superficial level, just getting excited by stuff like that. Um, but to be honest, I didn't really know what engineering was growing up. I started to look into it myself when kind of people in my family were like, you know, that level of curiosity and the way you like to apply stuff, there's a field for that. It's called engineering. Um, and I didn't know whether I would
Yeah.
want to do electronics or aerospace, actually. Um, and I went down the electronics route more because I just thought it would be more varied. I'd have a lot more options in terms of industries to go
Yes.
into.
Yes, I
Uh,
imagine you do.
yeah, so I followed a degree in
Yeah.
electronics engineering
Yeah.
at
Yeah.
Imperial College,
Yeah.
um, and so that was a really interesting experience.
Mm.
Um, I think
Mm.
in our class it was 1 in 6 were female, which
Really?
wasn't awful, but equally
Right.
not the best.
That a lot still. Yeah. Yeah.
Yeah,
Yeah.
and
But
you
it's
definitely
interesting, but
notice it. Yeah.
sorry, say again. I interrupted you there. Go
No,
on.
it's okay. I was just going to say you definitely notice it from the
Notice it.
get-go as soon as you
Yeah.
join that
Yeah.
field,
Yeah.
that it is
Yeah.
male dominated. But I think that's
It,
changing a lot.
Yes, I do. I certainly see the seeds of that happening, but it's also interesting, just in general, that you said that, you know, you had interest, inspiration, some of which came from perhaps members of the family, your family, and other people. But sounds like your school didn't necessarily, you know, introduce you to what engineering was. You sort of did it off your own back. And I've heard this a few times. Again, maybe things are changing a bit more as we go
Mhm.
on, but, you know, it's catching people as well, isn't it? I think at that much younger age, when they might be
Absolutely.
choosing STEM subjects, and And even we've had discussions in the past with some people on some of our podcasts here of, like, parents can sort of think, well, why don't you go and do accountancy or one of the service in or law or whatever. I think there's a misunderstanding sometimes of what engineering can provide in terms of a fantastic, well-paid kind of career path, and something which is really much more interesting than, oh, you're getting your hands dirty sort of approach. And I think that needs to come through maybe schools as well. But yeah, it was interesting that I don't know if schools, I don't think schools understand what engineering is, perhaps. I don't know, but
I think, like you say, it's changing a lot, and I can see it when I look back at school. Sorry, even if I go visit my old school, I can see there has been a bit of a shift in mentality. Like, computer science is now offered as a GCSE or A level. I hadn't even touched coding before I went to university, and very much felt on the back foot within my own degree. I think the extent at school was, I also went to an all-girls school, so that probably didn't help in that sense.
That's interesting. Yeah.
But I did have a physics teacher who was absolutely lovely and kind of saw my interest and gave me a circuit board, or like a breadboard, to play with, and was like, why don't you go home and try create this circuit, and like completely separate to the curriculum, and I'll talk you through it if you come back after school. And so that definitely helped. But I think you're absolutely right.
Teacher.
You need exposure to engineering from a young age, because there is a massive misconception about what engineering is. And I was lucky that I have a family that were happy to push me in that direction and really support in that sense. But you're right, there's a lot that don't do that. And some other parts of the family, I still remember when I said I was doing electronics engineering, or just I'm an engineer, it was literally like, oh, do you have to work on a construction site? And do you wear a hard hat? And I was like, what? I was like, that's literally not what engineering is.
No.
And once you do realize what engineering is, it's so exciting, because it's literally forms a part of every day of everyone's lives. And I think there needs to be more weight and value put on that, because it is a great career path. And with the way the world is moving, the innovation coming from engineering is pushing so many different industries. And 100%, you need to start back in school. I think it's almost too late when you start at university.
Agreed.
And I think companies are starting to realize that now too. And there's a lot more outreach to schools, because someone's already chosen a degree by the time they go to university. And equally, there is an extent of apprenticeship. That's another really good way to do it. You don't have to go to university. Hands-on experience can almost be better sometimes for certain students than to sit in a classroom and learn. But there needs to be that kind of mentality to push that.
And it'll take a while. We're starting to see signs of it. But absolutely agree. And from your point of view as well, just going back in your career, you were mentioning that you worked with Mercedes F1 as well. Was this directly before moving over to Space DOTS?
Yes, exactly. So,
and that sounds hugely exciting. I think a lot of people will, a lot of people get very excited on F1, and something that seems to go across a lot of different sectors, because I guess there's so much high pressure innovation going on, I guess, that what sort of things did you find there that, is there a big overlap in terms of what you learned there and what you're doing now with the space sector, I guess?
It's really interesting. F1 and space are always two industries that come up with a lot of excitement and fascination when you speak about them. And it's really interesting to see in F1, when you talk about space, everyone gets really interested, really excited, their eyes light up. And then when you talk to people in the space industry and you talk about F1, the same thing happens. And it's that mutual respect that both are working at really the highest level of technology and innovation. And like you say, really pushing the boundaries. I think for myself, and I mean, the reason I switched between industries is I wanted more of a challenge than what I was experiencing in F1. I had done 5 years of it. I'd learned a lot. But but I felt like I could take that knowledge elsewhere and really help another industry. And on top of that, F1 is not that impactful, I suppose, to society. I think there's certain tech that you develop in F1, and eventually it does end up in automotive safety, for example.
Right.
But space has a real societal or potential for societal impact of a real positive change. And that's something that really pushed me to switch over. But I think it's probably something I got hired for, was that F1 knowledge that I've got.
Right.
Because there is absolutely a crossover, but I'd almost say that F1 uses much more advanced materials. It uses much more advanced tech, much more advanced sensors, but it's because the space industry has to have a lot more weight on reliability and space environment and flight heritage. And so there's this kind of like legacy in the space industry that hasn't quite caught up necessarily to all of the tech that is currently available.
Interesting. Yeah.
And I think it's really interesting to find that crossover point, because absolutely there is stuff that you just can't use in space because it won't work. It just doesn't have that same level of reliability. Right. However, there's definitely a happy medium where there's tech that's not been unlocked yet for the space industry. And I mean, that's where Bianca's initial inspiration, even with materials, came from. They wanted to use all these new materials to reduce mass and have faster manufacturing times, for example.
Right.
But the space industry generally drags their heels on newer materials. But understandably so. I can understand, when the safety behind it is a lot more important than in F1. Yeah. So there is a happy medium between the two, and it's been really interesting for me to kind of explore that and see where that compromise is, that we can use this new technology, but we can't use that because, that's just not going to work.
That's interesting. Yeah. And do you think that sort of compromises the sort of where it is going to change over time? Because, there could be new materials that at the moment the industry is sort of, balking at. Just I'm using materials as an example. Mm-hmm. But presumably, to do the sort of stuff we want to do space-wise, to go to Mars or to the moon more to use its resources, there needs to be more innovation to continue. So presumably that will change, will it? Or it's gradually changing?
Exactly. I think it is definitely changing. And you're completely right. To achieve what we want to achieve, we need to embrace some newer technologies and also accept the risk that might come with them.
Right.
You need to, kind of in the way SpaceX does, you fail fast, you learn fast. And
yes.
There is, of course, a balance with the money that you have to spend on that failure. That I completely get it. But there is definitely a changing approach. Like now in the space industry, especially in startups, new space, SMEs, we're using so many more like COTS components, where in the past you just wouldn't touch them because they've got no radiation testing, they don't have flight heritage, etc. But now there's this movement towards COTS because it's more affordable. And actually, if you take an automotive standard COTS component, this doesn't go for everything, but there is a likely possibility that it will survive a LEO environment, for example. So there definitely is this shift in mentality that there are certain things that we can now use in the space industry, and there's a lot of companies that are trying to do that, and it's potentially bigger primes and government agencies that are the ones that are slower to change.
Yes.
Because there's so many processes to do so.
Yeah, which I suppose can be a bit frustrating for people who are trying to sort of innovate and push the boundaries. But I suppose that's always been the case with any frontier, isn't it? I guess.
Exactly. Yeah.
Really interesting, though. Really interesting. Well, I mean, we've been chatting away there. It's for about half an hour already.
Oh, nice.
But,
time flies.
Yeah, time flies. That was really interesting, Sophia. And I mean, hopefully, from our point of view at Advanced Engineering as well, we can get perhaps yourself or one of your colleagues or Bianca to come and present again.
Sure, yeah.
Because as well, we've got a lot of people who'll be in this audience as well for this podcast who sort of are coming from lots of parallel sectors like F1 and space, defense, aerospace, automotive, of course. And one of the things I think that we find that makes our event work so well really is that, and I guess like a lot of moving forward in innovation and technology, is that people looking over one another's shoulders and finding out things that they didn't realize were out there, because they've come out of their own silos, as it were, perhaps a little bit, and yes. And this is one of the sort of reasons why we like doing this as well, so that we can, there might be areas that, from your point of view, that you could hook up with on a new material that's being used in another sector, or vice versa. So
for sure. I think really, cross collaboration between sectors is so important and extremely useful. There is so much knowledge that can be shared, and I think as engineers generally you do just want to achieve the most technologically advanced or the most innovative product that you can, and if you're able to share that knowledge to an extent between sectors, you can really push that boundary and that needle a lot faster and further. So it's really great what you guys do to bring all of those different industries together.
Well, if you also have any, not sure if you do this, but if you've got any demonstrators that you want to bring to the show, we're happy to showcase them of anything that you've been putting up there, awesome, in one of our areas. But that might be something to talk about down the line. But well, so it just leaves me to say thank you very much, Sophia, for joining us. Sophia Ahmed-Ashford, and you are lead electronics engineer at Space DOTS. Thank you so much for joining us, and thank you to everybody for looking and or listening to this podcast. To see more podcasts from us, go to www.advancedengineeringuk.com. You can see lots of the editions that we've been doing, and we'll be carrying on doing these down the line with innovators and people who are making things happen across various sectors in manufacturing and advanced engineering. Thank you very much, Sophie. Thanks for joining us.
Thank you.
See you soon.
That was a pleasure.
Bye, everybody else.
Speak soon.
Bye-bye.